morning, my dear students. My name is Andrei Sharma, working as physics lecturer in one of the reputed institution in Hyderabad. Today, we are going to know about collision. Strong interaction among bodies, exchange of their momentum, kinetic energy, etc. is called collision. Collisions means the strong interaction between or among bodies can exchange their momentum or kinetic energy, that is you call collision. So what is collision? The interaction among the bodies which can exchange their momentum or energy is called collision. Okay, so there are two types of collisions: elastic and inelastic. So in case of elastic, momentum as well as energy both are conserved before or after collision. Okay, if only momentum is conserved, it is said to be inelastic collision. Okay, now we are going to know about final velocities of two bodies if they have elastic collision. Okay, so let us consider two spherical bodies, okay, of masses m1, m2. One moving with velocity say u1, another one with u2 velocity along a straight line. Suppose if they are collided, then after the collision there is no change in their masses, but their velocities changes. Say first one v1, okay, second one v2. So if this collision is elastic, you can say momentum as well as energy both are conserved. If it is inelastic, only momentum is conserved. Okay, so remember, according to conservation of linear momentum. Okay, so momentum on first body, m1 u1 plus momentum on second body m2 u2, that is equal to after the collision their velocities are changed, so momentum on first body becomes m1 v1, okay, plus second body becomes m2 v2. Okay, so you bring up m1 terms one side. Okay, so that is equal to, we can write m2 of v2 minus u2. Okay, it is about conservation of linear momentum. So remember, whether it is elastic or inelastic, it follows conservation of momentum. Okay, now if it is, the collision is elastic, then it follows kinetic energy also, no? So according to conservation of energy, okay, so according to conservation of energy, total kinetic energy before collision equal to total kinetic energy after collision. Okay, so kinetic energy on first body half m1 u1 square na, plus second one half m2 u2 square. Okay, so that is equal to kinetic energy after collision half m1 v1 square plus half m2 v2 square. This is total kinetic energy before collision and this is total kinetic energy after collision. Okay, so you can bring m1 terms one side, no? So thereby you get half m1, okay, u1 square minus v1 square equal to half m2 of v2 square minus u2 square. Okay, take this as equation 2. Okay, say this is equation 1, the other one is 2. Okay, now divide second one by first one. Okay, so half m1, okay, a square minus b square now, so you can write u1 plus v1 into u1 minus v1, okay, that is equal to half m2 of v2 plus u2, okay, into v2 minus u2. So this divided by first one, m1 of, now, so m1 of u1 minus v1, okay, by second one, m2 of, v2 minus u2, okay, both sides half is there, no, you can cancel, okay, m2, m1, this u1 v1, u2, v2 minus u2, v2 minus u2, or cancelled. So this is left. Now u1 plus v1 equal to v2 plus u2. Okay, so this you can take to other side now. So u1 minus u2 equal to v2 minus v1. So we can say this is relative velocity of approach to relative velocity of separation. So very important question in IPE. You can expect for 4 marks, that is, prove that in case of elastic collision, relative velocity of approach equal to relative velocity of separation. So in case of elastic collision, right? So relative velocity of approach, right, is equal to relative velocity of separation, right? So you can write v2 is equal to v1 plus u1 minus u2, so take this as equation 4. According to conservation of linear momentum, we know total momentum before collision, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So instead of v2 you can write v1 plus u1 minus u2, okay. So thereby by simplifying you can find final velocity. So m1 u1 plus m2 u2 equal to m1 v1, right, plus m2 v1 plus m2 u1 minus m2 u2, okay. So you bring all u1 and u2 terms to left side, okay. So this, if you are taking it to left side now, you get m1 minus m2 into u1 plus m2 u2 plus m2 u2, because if you are bringing it to other side you get plus, so 2m2 u2, okay. So that is equal to, in these two v1 common now, okay. So you get final velocity of first body. Okay, after the collision. See, first body velocity v1 na? So that will become, m1 minus m2 by m1 plus m2 of u1. Okay, plus 2m2 by m1 plus m2 of u2. So this is the final velocity of first body. Similarly, you can find the final velocity of second body also. How? Over here you eliminated v2 now, so you got v1. So if you eliminate v1 now, you can find v2. Okay, so v2 minus v1 equal to u1 minus u2 now. Therefore v1, okay, v1 is equal to v2 minus, okay, so this will become minus and this will become plus. Okay, so again you substitute in the conservation of momentum. That is m1 u1, right, plus m2 u2, no, equal to m1. So instead of v1 you are now writing v2, okay, v2 minus u1 plus u2, okay, plus m2 v2. So in this case also you bring all u1 and u2 terms to left side, okay, m1 u1. Okay, so this minus m1 u1, if you take to other side, you get plus now, plus. Next, m2 u2. Okay, so this m2 u2, no, m1 u2 take to other side, minus now, okay. Now, this is equal to, so here v2 is common, no? You can write m1 plus m2 into v2. So m1 u1 plus m1 u1, nothing but 2 m1 u1, no? Plus m2 u2 you can take common now. So this you can take to other side, no, by m1 plus m2 by m1 plus m2. So that is final velocity of second body, no. So what is final velocity of second body? 2 m1 u1 by m1 plus m2, okay, plus m2 minus m1 by m1 plus m2, okay. So that is about final velocity of second body. Now, so in case of elastic collision, the final velocities of two bodies, no, m1 minus m2 by m1 plus m2 into u1, right, plus 2m2 by m1 plus m2 into u2, no. So suppose the two bodies are having equal masses. So let us consider two bodies of equal masses. Okay. So special cases. Say first one, the two bodies are having equal masses. That means mass of first body and second body both are having equal masses. Okay, suppose two bodies you have taken, both are having equal masses, had an elastic collision. Okay, so in case of elastic collision, these are the formulas for final velocities, no? Now in this case, both are having equal masses. So put m1, m2 equal masses. So final velocity of first body m minus m, no, 0 by 2m, no, into u1 plus 2m, no, by m1 plus m2 is also 2m now, into u2. So you can write v1 is equal to u2, no. And about second one, see, v2 is equal to, no, 2m by 2m into u1 plus m minus m 0 now, so 0 by 2m into u2. So you know this is u1, 2m cancel now, so v2 equal to u1. So what do you notice from these two? We can say that after the collision, first body velocity, final velocity of first body equal to initial velocity of second body. Final velocity of second one is equal to initial velocity of first one. That means after the collision, the two bodies have exchanged their velocities. No? See, v1 u2, v2 u1. That means after the collision, the two bodies have exchanged their velocity. Okay, so remember, in case of elastic collision, if the two bodies are having equal masses, after the collision, the two bodies exchange their velocity. Now we'll take second special case. Okay, second one. Suppose you are considering a heavier body and a lighter body. Okay, so lighter body at rest, heavier body is moving. Suppose this heavier body hits lighter one. Then you want to know their velocities after the collision. Okay, so I am taking one heavier body which is moving with velocity say u1, okay, and a lighter body at rest, means it is not moving. Okay, now substitute this in the formulas. So here, you know, m1 is very much greater than m2. Okay, so m1 minus m2 by m1 plus m2 now. So m1 is having two large value. Say it is 1000. Say m2 1. So 1000 minus 1, 999 now by 1001. Say this ratio is almost equal to 1 only. No? So into u1 means v1 is equal to u1. Any of the second body at rest? No? So this part will become 0. That means whenever a heavier body hits lighter body, you will not find any change in the difference of its velocity. Means almost same. No? Now about second one. So 2m1 by m1 plus m2. So you know m1 is having very large value, no, than m2. So we can take 2000 by almost 1000 now. So that is why 2u1. That means when a heavier body hits a lighter body, this will fly in air with double the velocity. No? 2u1. Okay? It is about heavier body hitting a lighter body. Okay, now let us reverse the situation. Lighter body and a heavier body. Heavier body at rest, lighter body is moving with certain velocity. Okay, so here you know m2 is very much greater than m1. Okay, so when a lighter body hits a heavier body at rest, so here m1 small value and m2 is large value. That means minus only now. So this final velocity of first body is minus u1. Okay, say 1, this is 1000. Minus 999 na, by 1001. So this ratio is almost equal to 1 with negative sign. So we can say when a lighter body hits heavier body, it is almost coming back with the same speed. Okay, now about this one, final velocity of second body. Okay, so 2m1 by m1 plus m2 now means 2 into 1 by say 1001. So it is almost 0 only we can say. No? So lighter I am taking 1 to understand about the concept. Heavier I am taking now 1000. Okay. So 2 into 1 by 1000 plus 1. So almost 0.00 no. So that is why this velocity is 0. That means when a lighter body hits heavier body, you can find there is no change in the velocity of heavier body, right? And lighter body is almost coming with same velocity in opposite direction. Consider two spherical bodies of masses m1, m2. Okay, second body is at rest. So let us suppose first body hits the second body. Okay, so after hitting, say first body is moving with certain velocity, say v1 at an angle theta 1. Second body makes an angle theta 2 with initial direction, okay, velocity v2. So it is called collision in two dimension. Okay, so according to conservation of linear momentum, okay, in x direction. So first body mass is m1, it is moving with velocity say u1, plus second body m2 is at rest. So corresponding velocity taken 0. Okay. So that is equal to, in horizontal direction you are taking now. So resultant velocity of first body v1, second body v2. So velocity resolved into two components, horizontal, vertical. This also horizontal, vertical. So both the horizontal components are added now along x direction. So you can take m1 v1 cos theta 1. So v1 cos theta 1 is the horizontal velocity. Okay. Now second one, m2 v2 cos theta 2. So it is about conservation of linear momentum in x direction. Similarly, you can take in y direction also. According to conservation of linear momentum, say in y direction. Okay, you see the body is moving only in x direction in the beginning. So now vertical component of velocities. No, so this spherical body is moving only in x direction. So that is why its vertical component is 0 now. So m1 0 plus second body, you already know it is at rest, it is not moving. So that is why m2 into 0, okay, equal to m1 v1 sin theta 1, because horizontal is v1 cos theta 1, no, vertical v1 sin theta 1 na? So that is why m1 v1 sin theta 1 minus, because you see the second body is going down now, so m2 v2 sin theta 2. Okay, so this is about conservation of momentum in y direction. Okay, so you have taken two bodies. No, M1, M2. Second body is at rest. So your first body hitting the second body. So thereby they are moving at an angle theta 1 and theta 2 with initial direction. Okay, so if it is an elastic collision, definitely holds conservation of momentum and also about conservation of kinetic energy. Okay, so whereas IP point of view, you can expect one 4 marks question. Okay, about conservation of momentum in case of oblique collision, such that the sum of the angles is 90 degrees for equal masses. Okay, so let us consider two spherical bodies having equal masses. Okay, so you have to prove that sum of these two angles is 90 degrees. Okay, now very simple, that is, if this collision is elastic, it follows conservation of momentum and also conservation of kinetic energy. Okay, so we are assuming that the two bodies are having equal masses. Okay, so mu plus second body is at rest now, so corresponding velocity taken 0 equal to m v1 cos theta 1 plus m v2 cos theta 2. Okay, this is all in x direction. So you want to take it in now in y direction. So one is moving upwards now, the other is going downwards. So that is why negative sign. Okay, so both are having equal masses. Okay, so first equation, when you further simplify, say m is common now, m you can cancel. So you get u is equal to, okay, u is equal to v1 cos theta 1 plus v2 cos theta 2. Take it as equation 2. Okay. Now, the second one you see, left hand side totally 0, right? M also you can take common, no? So 0 by anything, 0 only. So the other equation, 0 is equal to, right? You can write v sin theta 1. So v1 sin theta 1 minus v2 sin theta 2 equal to 0. You can take this equation as 3. Okay. So first one, you can write conservation of linear momentum, no? So this is first equation. So the other two equations are, u equal to v1 cos theta 1 plus v2 cos theta 2. Okay. Third one, 0, because see left hand side totally 0 now, and further if you take m also to other side 0 by anything, 0 only. Okay. And we are assuming the collision is elastic. So if the collision is elastic, definitely it follows conservation of momentum, right? And also energy. No? So total kinetic energy before collision equal to total kinetic energy after collision. So in the beginning, only first body is moving. No? So that is why half mu square. Okay? Second body is at rest, no? So it is not taken. That is equal to, after the collision, first body mass changed to v1 now. So half m v1 square plus second one, half m v2 square. So what do you notice? Half is common now. You can cancel. So you get u square is equal to v1 square plus v2 square. Okay, so this can be taken as equation 4. Okay, now suppose you are squaring and adding 2 and 3. Okay, squaring and adding 2 and 3. So squaring and adding of second and third equations. So when you are squaring, no, left side u square and the other is 0, no, so you get u square only, no. Now right side you see v1, right, v1 cos theta 1 plus v2 cos theta 2 whole square, okay, plus second one, you know, v1 sin theta 1 minus v2 sin theta 2 whole square, okay. So when you further simplify, it is in the form of a plus b whole square now, so you will get v1 square cos square theta 1 plus v2 square cos square theta 2, okay, plus 2ab means 2v1 v2 cos theta 1, right, cos theta 2, okay, plus next one, you know, v1 square sin square theta 1 plus v2 square sin square theta 2, right, minus 2ab now, so 2v1 v2 sin theta 1 sin theta 2, okay, a minus b whole square formula, okay. So you know, these two, in these two v1 square is common, and you know, in these two v2 square is common, right. So when you further simplify v1 square, no, into 1, why? Because cos square theta 1 plus sin square theta 1 is 1, right, plus v2 square into 1, right, plus 2v1 v2, you can take common, no, so you know, cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, nothing but you know, it is in the form of cos a plus b, no, so that is why it can be taken as cos of theta 1 plus theta 2, okay, that is u square, okay. But you know, according to fourth equation, u square equal to v1 square plus v2 square now, so instead of this you can write u square, no, okay, so u square is equal to, okay, u square is equal to, instead of v1 square plus v2 square, we are writing u square, no, according to fourth equation. So plus 2 v1 v2 cos of, you know, theta 1 plus theta 2, okay. So this u square is cancelled, that is by taking it left, no, so you know, 2v1 v2 cos of theta 1 plus theta 2, right, equal to 0 now, so when you further send this to other side, that will also become 0, right, so cos of theta 1 plus theta 2 equal to 0. You all know when does cos value becomes 0, that is when theta 90 degrees, no. So we can say sum of these two angles is. Now we are going to know about quotient of restitution introduced by Newton. So the elastic collision of the surface or the body is known by Newton about quotient of restitution. Okay, so how you define quotient of restitution? It is a ratio relative velocity of separation to relative velocity of approach. Okay, so whenever this value equal to 1, we say the collision is perfectly elastic. Okay, so whenever this is 0, we say the collision is perfectly inelastic. Okay, so in between we can say semi-elastic. So how to find E value? Let us suppose you are considering a body, okay, dropped from h1 height, okay, then after striking the ground, say it rebounds to h2, okay. So you know, before or after the collision there is no change in the velocity of second body. So first body is this ball, second body is surface, okay. So second body starting velocity 0, final velocity is also 0. Now you want to find velocity of first one. So it is dropped through height h1 now. So making use of relation v square minus u square equal to 2a, yes. Okay, so final velocity means initial only, no? So u1 square. You know, starting velocity of a freely falling body is 0. So that is why u taken 0. Okay, v taken as u1 means the velocity with which this body is striking the surface. Nothing but you can say starting velocity of first body. Okay. Acceleration for a freely falling body, you know, Gina, displacement h1. So you can take u1 is under root 2g h1. Now, you know, after striking the ground, it rebounds to h2. So using same relation, you can find v1 is under root 2g h2. Now u1 known, v1 known, u2 and v2 are also known. No? So substitute in the formula. Okay? v2 0 na minus v1. See, it is moving in opposite direction, no? So that is why taken minus sign by u1. So starting velocity of first body, you know, 2g h1 minus 0 na. So you get E equal to, okay, 2g h2 by 2g h1, no? So 2g cancelled, under root h2 by h1. So how you measure E? Called quotient of restitution? No units, because it's a ratio, no? So how you measure E? Root over h2 by h1. So h2 final height and you know h1 initial height. So thank you for watching this video. Please like, subscribe and forward to your friends. Okay, so this is only part 1, and in the second part I am going to do problems that are related to this collisions, and I can give you more updates related to this JEE mains, okay, NEET, EAMCET. Okay, please like and subscribe my channel. Thank you.